Welcome to an exciting educational video brought to you by Chrysolite Tutors. Here we master calculations, we excel in science, and we learn anytime. So today we'll be looking at calculus, past questions in JAMB. So we're treating every area of calculus that appeared in past questions for JAMB exams. So as way of learning objective, we're looking at limits, differentiation rules, application of differentiation, integration, and exam focus. So we'll be solving questions that are involving calculus. So the first one I have here is on limits. So it says that the limit of the function f of x is 3x squared minus 2x plus 1 as x approaches 1 is, so we're looking for that limit. So if you see this kind of question where the function is given, I'm writing it out like this. We are asked to get the limit as this function as x approaches 1. So it means that here we see x in this expression, we'll put 1. So by way of substitution, I would say 3 into 1, that is, instead of having x here, I put 1, then all square, minus 2 into 1, then plus 1. So this expression has been written as this, putting 1 where we see x. So when we compute, 1 square is 1 times 3 minus 2 times 1 is 2 and plus 1. 3 times 1 is 3 minus 2 plus 1. 3 minus 2 is 1. 1 plus 1 is 2. So the answer to this question is C. So number 2 question came out last year, JAMB 2025. It says if y is equals to 5x cubed, then find the derivative. Derivative dy dx can also be written as d dx of the function, whatever function you have, right? Okay, so the function we have there is y is equals to 5x cubed. So for differentiation, the general formula or rule is for polynomials is that you would add 1 to the power and at the same time divide the expression by the addition of what you got with the power and 1. Okay, so if for instance, example or e.g., have y is equals to ax raised to power n, yes, where n is the power of x. So for dy dx, it will now be this n multiplied by a, that is multiply the power with the coefficient na, then this same power add 1, sorry, not add 1, subtract 1, subtract 1, subtract 1, right? Okay, so I have, for this case, I have y is equals to 3 times 5 is 15, then x raised to the power 3 minus 1. So y or dy dx will now be 15x raised to the power 2. So that's what I have here as the answer. So the correct option is A. So the next question is still from JAMB 2025. It says the derivative f of x is equals to cos x with respect to x is, okay, so for trigonometrical ratios or expressions, the derivative of cos x is minus sine x. Already the answer is B. But for others, derivative of sine x is cos x. So there's a standard differentials for all of this. Okay, so the answer is B. Number 4 here, it still mirrors 2025 JAMB. It says limits as x tends to 3. This function, what will it give you? What will it give you? Again, what it means is that you should substitute x as 3 into this expression. So the first thing we'll do is to factorize the numerator. Numerator here is x squared minus 9, right? So I have x minus 3 and x plus 3. So this is difference of 2 square all over x minus 3. So by the time you cancel this out because they are common, the simplified expression now becomes x plus 3. But then we are asked to put x as 3. That is the meaning of this x tends to 3. So when we see x, we put 3 plus 3 give me 6. So the answer here is C, 6. Number 5 says given that y is equals to 2x raised to the power 4 minus 3x raised to the power 3 plus 5x minus 7. Why dx is. So this is a polynomial with 1, 2, 3, 4 terms. So we can differentiate each of the terms one by one. So we'll just apply the differentials for each term. So again, you use the general formula of y equals to x raised to the power n. So dy dx is the same thing as take the power and multiply the coefficient na, then x at the same time minus 1 from the power n minus 1. So this is the standard differential of a function. So we go ahead with the question. So dy dx of this expression becomes for the first term 4 times 2 is 8 x. At the same time 4 minus 1 is 3. So the power reduced by 3. Okay, minus second term is 3 times 3 is 9x. 9x raised to the power, then the power reduced by 1, 2, 3 minus 1 is 2, right? Then plus, now the power for the next expression or next term is 1. 1 times 5 is 5. At the same time, 1 minus 1 power is 0. So x to the power 0 is 1. So that is why the differential of 5x is 5. And for all constant term, 7 is a constant term without any form of variable attachment to it. So the differential of 7 is 0. So this is the final answer for that differential. So the answer is A. Okay, so if the displacement of a particle from time t is given by s is displacement, right? Then I have 3t squared minus 2t plus 5. Velocity of the particle at t equal to 2 seconds is, now for application of differentials in displacement, velocity, and acceleration, there's a relationship that exists between them. If I differentiate displacement to time, I get velocity. This. If I differentiate velocity to time, I get acceleration. So if we are starting from s is equals to whatever function, let's in terms of time, 3t, or let me say at, where a is a constant, right? If I differentiate this first one, I get second one. This first differential here is called first derivative. And again, if I differentiate this one again, and I get this one, then it is called second derivative. So I can express this in terms of, express acceleration in terms of this by saying d2s over dt square. This is acceleration. That is, if I differentiate from a distance straight by differentiating twice, I get acceleration. So from distance, if I differentiate the first time, I get velocity. Whatever I got as the answer of the differential, if I differentiate again second time, I get acceleration. That second time differentiation is called second derivative, while the first time differentiation is called first derivative. But for this case, I'm asked to differentiate, find velocity. So I'll differentiate this one first. Differential of this is 3t squared. By the time I multiply 2 by 3, I get 6t minus 2. So this is the differential. If I put t as 2 in this expression, or 2 as t in this expression, I will have 6 into 2 minus 2. 6 times 2 is 12 minus 2. 12 minus 2 is 10. So 10 is the velocity of this particular problem. So B is the answer. Number 7 says to find the stationary point, horizontal tangent of a function f of x, you must find where dy dx equals 0. So by definition, stationary point occurs when the derivative equals 0. By definition, stationary point occurs when dy dx equals 0, right? So that's answer B. Okay, so 8 says for a circle with area A is equals to pi r square. The rate of change of area with respect to the radius r is, so rate of change again is differentiation. Rate of change is you differentiate this with respect to this, that is A with respect to r. A is area, r is radius, right? So the A, the r here will now be, this is the power 2 times coefficient. So I have 2 pi, then at the same time 2 minus 1, that's the power, 2 minus 1 is 1. So 2r. So the A, the r will give us the circumference. So if you differentiate the area, you get circumference. You know that pi r square is area, right? And 2 pi r is circumference. So differentiate area, you get circumference. So the answer is B. Number 9 says the function f of x has a local minimum at x is equals to a. If f prime a, function f prime a, what this one means is that f prime means that I differentiate the function first time. If I have f prime prime, I differentiate the function second time, right? But this is what I'm looking at now in this question. They said if f prime a is equals to 0. So what it means that I differentiate the function first time and I put the constant a where the variable is, and whatever I've done there is becoming 0. That's what this statement is saying. Then f prime prime a is what? Okay, now this is just to help us to let us know the condition for second derivative test for minimal. There's what they call minimal and maximal. Okay, so the answer is C, positive, right? That f prime prime of A is positive. This is where you have uh, uh, second derivative tests. That if f prime of A is 0, and f prime of A is greater than 0, then f into x, that's f function x, has a local minimum at a. A local minimum at a. So this is the function. The local minimum at a is this condition to be met. And c is positive because when you say f prime prime of a greater than 0, it means that it's positive. You know the integer, this is the integer, the number line, right? Is 0. Everything here is positive. Everything on the left hand side is negative, right? After 0, I have 1, I have 2, 1, 2, 3, and so on. Here I have minus 1, minus 2, minus 3. So practically, this is f prime prime of a greater than 0 means positive. Here is greater. Anything on this side of 0 is positive. So that is why this is correct. Number 10 says if the velocity of a body is given by v is equals to t to square minus 4t plus 3. Its acceleration at t is equal to 3 seconds is, now velocity to acceleration, if you differentiate velocity, you get acceleration. So dv dt equals to acceleration. That's what it means. But then we have a function v, right? That is the d dt of this function, t squared minus 4t plus 3, right? That's to differentiate this function. If I do that, I'm going to be differentiating each of the term one by one. The first term, t squared, is 2t, right? Why? Because 2 multiplies coefficient 1. That is 2 times 1 is 2. Then at the same time, power reduced by 1. 2 minus 1 is 1. So 2t raised to power 1 minus 4t will give me 4 because the power of t here is 1. Then of course constant is 0 plus 0. So differential d v dt will give me 2t minus 4. So at this point we are asked to put t is equals to 3. T is equals to 3. This is where we're asked to do that. You understand? So we're going to put it there. So 2 into 3 then minus 4. 2 times 3 is 6 minus 4. The answer will give me 2. So 2 is option C. 2 is option C. So number 11 says, if f of x is equals to 3x squared minus 2x plus 1, then limiting as x tends to 2, what is f of x? What is f of x when x tends to 2, right? So I'll put f of x first of all. X squared, 3x squared minus 2x plus 1. So substitute when you see x is equals to 2. Substitute it there. 3 open bracket 2 all square minus 2 open bracket 2 plus 1. So 3 times 2 is 6 minus 2 times 2 is 4 plus 1. 6 minus 4 is 2. Okay, sorry, there's a mistake here. 2 square, there's a 2 square here. 2 square is 2 times 2 is 4. 4 times 3 is 12. So there's a 12 here. Yes. So 12 minus 4 is 8 plus 1, which will give us 9. So 9 is the answer. Right? The next one. The derivative of y is equals to 4x cubed plus 7x with respect to x is, so d dx of 4x squared cubed plus 7x. Okay, so I will differentiate this one. 3 times 4 is 12. At the same time, 3 minus 1 is 2 plus differential of 7x is 7, right? So the answer is already gotten as A. Number 13, it says the velocity of a particle when displacement s is equals to 2t squared plus 3t plus 1 at t is equals to 3 is, again, this is displacement s is equals to 2t squared plus 3t plus 1, right? This is the t here. First of all, when we differentiate displacement, we get velocity. Displacement, you get velocity, right? So if I differentiate ds, dt is velocity. See, this s is actually this one. If I differentiate this one, I will get velocity, right? So differentiate this one now. Let's go. 2 times 2 is 4. That is power 2 times coefficient 2 is 4. 4. Then t. Then at the same time, 2 minus 1 is 1. That's t raised to power 1. Then plus 3t. We differentiate 3t, we get just 3. So the differential or ds dt, which is velocity, is 4t plus 3. But then we're asked when t is 3. So I'm going to put t as 3 here, or 3 as t. So when we see t, we put 3. So I put 3 in place of t plus 3 again. 4 times 3 is 12 plus 3. 12 plus 3 is 15. So the answer to this question is 15. 4. A is equals to pi r squared. The rate of change of area refers to the area radius is, again, this question has been repeated before. So I differentiate A is equals to pi r squared. You know that this is the formula for area, right? I say dA dr is 2 pi r. So dA dr is circumference, right? So the answer is B. Then 15, a function f of x has a local maximum at x is equals to a if f prime a, that is differentiate this first. You understand? If you put a inside the differential, you get 0. And at the same time, differentiate again. If you put a prime inside the second differential, less than 0 or minus, it becomes local maximum. Remember, we have talked about local minimum before. Minimum. Okay? And local maximum. So at this point, I want to give us the difference, the notational difference, the conditions to. So this is maximum. Local maximum, first differential must always give us 0. Second differential, and you put a inside the constant, less than 0 or negative is maximum. For local minimum, this is local maximum. Local minimum, first differential will always give you 0, but second differential will be greater than 0 or positive. So minimum is positive, maximum is negative. That's just the difference, the two of them. So number 15, you have function of a function. What do I mean by that? I have this linear function inside a trigonometric function. There's a function, linear function, or polynomial function inside a broader sine function. So I can write this one and say y is equals to sine theta, right? But theta is the same thing as 2x cubed plus 3x minus 4. So this theta has its own function, and theta is also a function of y. You understand? So it's a function of a function, But here we're asked to find dy dx. For dy dx, function of a function, we're going to be using what they call chain rule. For chain rule, what we do here is, first of all, we differentiate the inner function first, then bring it out to multiply the differential of this other function. So the first thing you do for chain rule is to break it into two distinct functions. Again, I'm having y is equals to sine, open bracket, 2x cubed plus 3x minus 4, right? So I now know that this is a function. Let's call this function theta. So I will say theta is equals to 2x cube plus 3x minus 4. That's the first function, right? Second function is y is equals to sine theta. So it's the same thing I'm written here again. That if I put this sine theta, and instead of putting sine theta, if I put this one here, I'm going to still get my initial question back, right? So for chain rule, you will say you will do like this: dy dx is equals to dy d theta, as this one, times d theta dx, as this one. So the two functions you have broken down into, you are going to differentiate them. Okay. Now, the first differential, we'll take some things off so that we can see properly. So I'll take this one off. So I'm going to start from this formula that I've written here. I'll start from this formula that I've written here. The formula is to differentiate the two functions. So dy dx is equals to, so I'll differentiate this one first. Recall that this dy dx is, you are differentiating, let me write this again. Y is equals to sine theta, right? That's the first one. So you're differentiating this one, dy d theta. So dy d theta is sine theta is actually cos theta. So I will now put cos theta here. That's the first one, this one. Then times, for the theta dx. Recall that theta, I'm putting down here, is equals to 2x cube times, no, not times, plus 3x minus 4, right? So I will differentiate this one here. I will say 3 times 2 is 6. So it's 6x square, right? This first one, plus 3. That's the differential, right? So I've gotten the answer, but I'll put everything in terms of x because I don't have theta in the initial question. So this will now become, instead of having cos theta, I'll say cos, open bracket, theta, recall, is 2x cube plus 3x minus 4 times, again, times this one, 6x squared plus 3. So the answer is this one because it's commutative. So I can bring this one in front. 6x squared plus 3. I close my bracket. Then cos 2x cubed plus 3x minus 4. Okay, so this is the answer here. C is actually the answer. C is the answer. Right. We'll go to the next question. So limits this function as x tends to 3. Again, we can factorize the numerator. And see whether we can okay, factorization will be a long way. So just substitute x where you have 3. So substitute 3 when you have x. So if I have x cubed minus 2x squared plus 6x minus 12 all over x minus 2. So substitute x is equals to 3. So when you see x, you put 3. So I have 3 cube minus 2 into 3 square plus 6 into 3 minus 12 all over 3 minus 1, right? So 3 times 3 times 3 is 27, minus 3 times 3 is 9, 9 times 2 is 18, plus 3 times 6 is 18, then minus 12 all over 2. Okay, so 18 will cancel 18. So 12 minus, okay, this is 1, sorry. This is 1 from here, right? So 27 minus 12. 27 minus 12. This is 5 and this is 1. Okay. Okay, let's check this again. Let's see whether we are correct. Substitute 3. 3 times 3, 9. 9 times 3. 3 times 3 is 9. 9 times 3 is 27. Yes. Then 3 times 2. 3 times 3 is 9. 9 times 2 is 18. 3 times 6 is 18. Okay, then minus 12. Okay, this one will cancel this one. Okay, then I have 27 minus 12 to give us 15. We don't have the options here. But 15 is the answer to this question. Okay, so number 18 say a particle moves so that its displacement x is equals to t cube plus t minus 3. The acceleration at t is equals to 1 is, so acceleration is differentiating twice. So you see displacement x, displacement x is equals to t cube plus t minus 3. So if I want to get v, v will dx dt, right? So velocity is what I got first. This differentiate this one. First term it will be 3t squared plus 1, right? So then acceleration a will now be dv dt. So differentiate this one. For a, I will get 3 times 2 is 6t. So this acceleration, this is t. But if t is equals to 1, acceleration is 6. So the answer is A. So number 19 says if f of x is equals to 3x squared minus 6x plus 2, the rate of change at x is equals to 2 is, rate of change at x, rate of change is just differential, first derivative. So again, if you do something like this, that means differentiate once. And if you do something like this, differentiate again. If you do something like this, differentiate the third time. So this is first derivative, second derivative, third derivative. But we're dealing with first derivative here. F of x, f prime of x is, I'm differentiating this one. Watch. 2 times 3 is 6. 6x, then 2 minus 1 is 1, minus, differentiate this one, you have 6. So this is the differential, but it's at the point where x is equals to 2, right? So I'll say 6 into 2 minus 6. 6 times 2 is 12 minus 6. 2 minus 6 is 6. So the answer is 6. 6 is the answer. 6 is the answer. There's no 6 at the option. Okay. Number 20. The derivative of y is equals to 4x cubed plus 7x is, so y is equals to 4x cubed plus 7, right? X. Okay, again, 3 times 4 is 12. X, 3 minus 1 is 2 plus 7. So this is the derivative of that question. Now evaluate evaluate limiting this function as x tends to 2. So I can do what we call factorization of the numerator. This is difference of 2 square. It's written as x square minus 2 square. The same thing as saying x minus 2 and x minus plus 4. So all over this one, x minus 2. So this will cancel this. What I have left is x plus 2 plus 2. So if it's x plus 2, we need to put where x is equals to 2. X is 2, so 2 plus 2 is 4. 4 is the answer. And differentiates y is equals to 7 raised to the power 4, 5, x raised to the power 2 plus 3. So you do it one by one. dy dx is equals to the first one. 4 times 7 is 28. Then x. Then 4 minus 1 is 3. Then minus 2 times 5 is 10. Then x. 2 minus 1 is 1 plus 3. So sorry, plus 0. Plus 0. So it now becomes 28x cubed minus 10x, right? 28x cubed minus 10x. That the answer is A. So find the stationary point of y is equals to x squared minus 4x plus 1, where x is equals to. The stationary point is you differentiate it and equate to 0 and find the value of x, right? So differentiate it. dy dx is equals to is 2x minus 4. So equate this to 0 now. So 2x minus 4 is equals to 0. Minus 4 will go to this side. So you have 2x is equals to plus 4. And divide both sides by 2. X will now be equal to 4 over 2. X will now be equals to 2. Okay. 25 says f of x is this. Find dy dx and put 1 inside, right? That's what this one means. You differentiate it and put 1 inside in the differential. So dy dx of this function is equals to 3 times 1 is 3, then x raised to the power 2, that's this first one, then minus 2 times 3 is 6, then that's I'm differentiating this one, then x, then plus 0. So dy dx is equals to 3x squared minus 6x. So I'm going to put 1 inside of this. So I have 3 into 1 or square minus 6 into 1. This is 1 square is 1 times 3 is 3 minus 6 times 1 is 6. So 3 minus 6 will give you minus 3. So this is the answer. So I hope this video has been informative for you. I'd like to thank you for viewing.